All right, ladies and gentlemen, I hope you have your dancing shoes on, because today we're getting ready to two-step. I know, it's bad, but the good thing is I'm here all year. Two-step equations, let's take a look. A two-step equation is simply an equation that has two operations in it. It's going to have addition or subtraction, and it will also have multiplication or division. Let's take a look at the steps to solve the two-step equation. Well, we all know by now that step number one is to write the equation down. Okay? After you get it written down, we're going to undo any addition or subtraction first by showing the inverse operation underneath both sides. After we do that, after we have the addition or subtraction taken care of, we're going to undo any multiplication or division by showing the inverse operation on both sides. Let's take a look at about 3 examples. On that first one, it says 2a plus 5 is equal to 17. Well, what two operations do we see? 2a means 2 times a, and then they're adding 5. When you're solving a two-step equation, we have to use reverse order of operations because we're undoing it. We're undoing what's been done to the variable. That's why we undo any addition or subtraction first. So, since they're adding 5, our first move will be to subtract 5 from both sides. When we do this, on the side with the variable, we've learned that it's going to cancel out. Mathematically, it's 5 minus 5, which is 0, and 2a plus 0 is 2a. So we're left with 2a is equal to 12. We know that 2a means 2 times a, so to undo the multiplication, we need to use an inverse operation of division. Since they're multiplying by 2, we're going to divide both sides by 2. Doing so is going to isolate the variable because 2 divided by 2 is 1 and 1 times a is a. And 12 divided by 2 is 6, so we're left with a is equal to 6. If we plug it in to check, if we substitute 6 in for the a, we would have 2 times 6, which is 12, plus 5, which is 17, which leaves us with a true statement of 17 is equal to 17. On the right side of the screen, we've got b divided by 3 minus 6 is equal to 2. Our two operations in this one are division and subtraction. Again, since we're undoing what's been done to the variable, we need to use reverse order of operations. So since they are subtracting 6, we're going to need to add 6 to both sides. When we do so, when we add 6 to both sides, on the side of the variable, it's going to cancel the 6's out, and we're going to be left with b divided by 3. On the right side of the equation, we have 2 plus 6, which gives us 8. Now we're left with just one step, and they're dividing by 3. The inverse of division is multiplication, so we're going to multiply both sides of that equation by 3. When we do so on the side with the variable, the 3's cancel each other out and we're left with b. So we have b equals 8 times 3. Well, 8 times 3 is 24, so we have b is equal to 24. I've included a third example today, and in that example we have negative 4 plus 3x is equal to 17. I just kind of switch the order on it, and we're going to take care of this. In this one we have addition and we have multiplication. We're going to undo the addition first. So they're adding 3x and negative 4, so we need to do what? That's right. We need to subtract negative 4 from both sides of the equation. When we subtract negative 4 from both sides, it's going to cancel out. on the side with the variable, leaving with the term 3x. And on the left-hand side, 17 minus a negative 4, we're going to use keep, change, so that's really 17 plus 4, and we're going to end up with 3x is equal to 21. Now we just have 3x to undo. Well, 3x means 3 times x, so we need to divide both sides of our equation by 3. When we divide both sides by 3, on the side with the variable, well, 3 divided by 3 is 1, and 1 times x is x. And so we have x by itself. And on the right-hand side, we have 21 divided by 3, which is 7. So our solution to this one is x is equal to 7. Hope this helped a little bit, guys. And like always, reach out to me if you have questions.